folks, welcome to example 4. So I've got another rational inequality. I got a fraction. I'll worry about the domain in a moment, but the thing I got to address first is that there's this greater than 2 situation happening over here. So I'm going to subtract 2 from both sides, and then I'm going to need to simplify my fraction. So when I start to look at this, oops, scooched my paper for a sec. All right, when I start to look at this, I'm looking at 3x over x minus 4 minus 2. What was my symbol? It would be greater than 0. And I picked greater than because it was a greater than over here. So now I need to rationalize. I need to subtract these fractions. And if I want to subtract those fractions, I'm going to need that LCD. And that LCD is going to be x minus 4, right? Because this is essentially 2 over 1. So I'm going to go ahead and I'm going to multiply this fraction here by x minus 4 over x minus 4. Because when you multiply anything by 1, you don't actually change its value. It's the multiplicative identity. So I have 3x over x minus 4 minus 2 times. This is going to be x minus 4 over x minus 4 greater than 0, right? And let me just go ahead and scooch this over here. So now I'm going to have 3x over x minus 4 minus 2 times x minus 4 over x minus 4. That's going to be greater than 0. And I'm going to remember to distribute that negative, that subtraction, not just to the 2x, but also ultimately to that negative 8, right? Because I have 2 times negative 4, which is negative 8, but I got to subtract it, right? 2 times negative 4, negative 8. Subtracting a negative 8 will ultimately be plus 8. We're going to get there. So this is going to be 3x minus 2x minus 4 all over x minus 4 is greater than 0. And I'm just going to continue to simplify this, right? Again, I'm going to distribute now. So I am looking at 3x minus 2x plus 8 all over x minus 4 is greater than 0. I have some like terms, so 3x minus 2x is just x, and I've got a plus 8. So here is my rational inequality in simplified form. So from here, once you get that simplified, it's a matter of setting numerator and denominator to 0. So if I want to see where is the numerator 0, that's 1 is x plus 8, 0. 1 is the denominator 0, that's 1 is x minus 4, 0. So my two interesting x values are negative 8 and 4. And when I say interesting, those are the ones that are going to show up on my sign pattern. So let's go ahead and make a sign pattern. And at this point, I'm going to use the faster method of making my sign pattern. I've talked about that in examples 2 and 3. And I'm going to play that out here. Now keep in mind, you can always use test points. Test points will always work. It just takes a little bit longer, okay? So I'm going to scooch this up a bit so that I have a little bit more space. And let's start to make that sign pattern, okay? So sign pattern is just, it's a smushed XY axis. Okay, so I'll go here, X. All right, so we're gonna have an X down here. And then I'm gonna put my rational expression of X plus 8 over X minus 4. All right, so let's go ahead and see what our signs are, right, in terms of plus, minus, 0, and then maybe the D and E. So negative 8 was an issue, or I should say interesting, and 4 was an issue. That's going to split up my number line. All right, when x was negative 8, right? If x is negative 8, then this fraction has a 0 in the numerator. Anytime you have a fraction with a 0 in the numerator, the value of the fraction is 0. When x was 4, the denominator was 0. Anytime you have a denominator, or fraction where the denominator is 0, that fraction is undefined. It does not exist, D and E. Okay. Now you could use test points, so I could put something like 5 over here and then keep track of those signs, pluses and minuses. But this is how I'm going to do it. I'm going to look at my inequality, which is ultimately, if I look at the lead term in the numerator and the lead term in the denominator, right, I'm looking at x over x, which simplifies to 1, which is a positive number. So I know I have a lead positive. So if you want to figure out what your lead sign is, your rightmost sign, take a look at the lead coefficients in the numerator and denominator in ratio, right, as a fraction, and just determine if they're positive or negative. And in this case, positive x over positive x is positive 1, so this is positive. And then because these factors technically have an odd degree, we discovered Anytime you have factors with odd degrees, the sign is going to alternate. So if I'm moving from around x equaling 4, right? I look at x minus 4, it's to an odd degree because that's odd. I know it's going to change sign. As I move this way, I want to cross x equaling negative 8. Negative 8 came from x plus 8. Because that had an odd degree, it's going to change sign, so it's going to go from negative to positive. Okay, and just to give you a counter, right? Let's say, just for example, this had been squared. Okay, then I'm going to change it back because it wasn't really squared, but I do want to show you how this plays out. All right, if this had been squared, and then I'll go back to the correct one. But if it had been squared, what I would have done is, okay, my lead terms would have been x squared over x squared. So the numbers would have been 1 over 1, which is 1. This would have still been positive. As I move this way, I'm crossing 4. It came from x minus 4, which had an odd degree, so it's going to alternate signs. As I move this way, I'm going to cross negative 8. Negative 8 came from a squared, right, an even, a factor that had an even power, so it's going to stay the same. It's not going to alternate. All right, so that's how you play that out. Now, again, this didn't have a square, so as I move across negative 8, it should change sign. So I should have a plus here. And ultimately, when I go to look at my answer, I want, where is this thing greater than 0? So I want to collect positives. So I want this interval and this interval, keeping in mind you have a negative infinity over here and a positive infinity over here. So any x value between negative infinity and negative 8, or 4 to infinity, would result in this rational expression being positive. Or if we go all the way back to our original, let me scooch this down just a wee bit, it would result in this rational expression being greater than 2. And you could always test it. You could pick something like 5, right? If I plugged 5 in, I would get 15 over 1. Right, and 15 over 1 is greater than 2. So you can always test the actual x value, or your intervals out if you'd like to. All right, thanks so much, everyone. Bye.